Thank you everyone for coming out. We're beginning now with the Saving Satoshi workshop. Saving Satoshi is a browser-based online game. It is an RPG where you can play along and learn the very basics of technical Bitcoin. We'll be playing through the game together with chapters 1 and 2, play along with the screen, and then we're going to break up that we can continue chapters 3 and 4 on our own with some assistance from myself. And at the end of chapter 4 in the game, we will be there is a clue for capture the Bitcoin, so you can win big prizes through your commitments to playing along. So I'll ask everyone to begin by opening up their computers and heading to savingsatoshi.com. Savingsatoshi.com, and we can go right ahead right here, and we're going to hit start. So we'll play along in the browser. I'll be walking us through, and if anybody has any questions or they get stuck or they would like some clarification about anything we're going through, I'm happy to answer those questions. So we begin right here, chapter 1, Secrets in Plain Sight. The year is 2139. The last Bitcoin is 2 weeks from being mined. For months, a clock has ticked down in Satoshi Square. Up until this point, every block has had some kind of Bitcoin reward, a subsidy. This is the only way new Bitcoins come into existence, but soon it's about to change. After over 100 years, the issuance schedule for Bitcoin is coming to an end. The world awaits for the last block with a subsidy to be mined. It is a historical event and the end of an era. Suddenly, the network grinds to a halt. So let's begin right here with chapter 1. I would like to get some audience participation, so if anybody would like to come up and play as any of the characters, do we have any volunteers from the audience? Do we have a nice Deborah or Vanderpool? Would anyone like to come on down? Yes, come on down, Evan. All right, and one more person. Okay, I can play as the other character. Very good. So, yep, come on up. I'll be Deborah. Moments later, your hover screen activates. Thomas Vanderpool, as the well-dressed CEO of Bitray, you run by far the largest mining pool in the world. You also manufacture Bitcoin mining machines. What is happening? Is Bitcoin dying? Oh.
Test.
Yeah.
Let's start from the top. Yes, I am Deborah. And yes, I do. The Vanderpools, my well-dressed daddy and his well-dressed daddy before him, have been mining since block 21,000. That's why I can confidently say that miners across the world are causing these delays by turning off their machines. This is a protest. No one wants Bitcoin to stop being issued at 21 million. Miners cannot survive on fees alone.
On your Everything watch, you receive a Whiskerware brand holocat from someone using the name Satoshi Nakamoto. It's like any other e-hologram, but this one is shaped like a cat. You open the holocat by booping its nose. Bitcoin is not dying, but it needs your help. Don't forget the cat. Satoshi Nakamoto.
Satoshi? The Satoshi from the white paper? No, it couldn't be. They've been presumed dead for over a century, haven't they?
You better get to work. I can help, but you have to start meow. Very good. I'm going to mirror my screen, actually. Your first challenge. So now we are going to begin with the interactive section. Your Bitcoin is censorship-resistant money. Anybody can send money by broadcasting a transaction to the network. After broadcast, transactions are packaged up into blocks by miners. Miners compete against other miners for the privilege of building on the chain. This is what keeps Bitcoin decentralized. Satoshi Nakamoto, the pseudonymous inventor of Bitcoin, also mined the first Bitcoin block. He left the world a secret message in the very first Bitcoin transaction that was ever made. Your first challenge is to find and decode it. Very good. So part of our first exercise is that we are going to be using a block explorer. Can I get some feedback from the audience, raise your hand if you are familiar with a block explorer like mempool.space or similar. Okay, very good. Can we raise our hand if we have never used a block explorer before? Yes, okay, I see a few hands. So we're going to begin with the Genesis block. This is the first block mined by Satoshi in January 2009, and we're going to look at the first ever block that was mined and the message contained within it. So we open up a browser here to the Blockstream Explorer, and we can see block 0, dated January 3rd, 2009. And you can see there was one transaction in there. That's the Coinbase transaction, which is the block reward that is issued when a block is mined. We can view more details about the transaction here, and we can see that we have a single Coinbase transaction with a pay-to-public key output for 50 Bitcoin, and there's some information saved here in the script sig hex. So it seems that this is what they want us to get. So scroll down and expand the details on one transaction that is stored in this block. Find the Coinbase input and look for the scriptsig hex. The value next to it is an encoded message. Copy that value and paste it into the code block. So we're going to go ahead and take this value right here, copy it, and paste right here into our browser. And the green shows this is the correct data. So now we are going to decode that. So we have a terminal open right here, and the variable from the previous step has already been saved. So we just need to copy and paste this command into the terminal in the code block and press enter. And what that will do is it will decrypt what that hex information is that was in the Coinbase transaction and give us some information about it. So we copy it right here by clicking and paste into the terminal. There we go. The times, January 3rd, 2009, a chancellor on brink of second bailout for banks. So this is the information encoded by Satoshi Nakamoto into the Genesis block of the first Bitcoin transaction. And some more trivia, Brink, the Bitcoin open source organization, takes its name as a reference to this brink of second bailout for banks. So has everyone followed along up to this step to continue? Get some feedback from the audience. I see some good thumbs up. Excellent, let's keep going. We've completed the first challenge. Very good. Now we're going to dig into what is in a transaction. There's two main components of a transaction, the inputs and the outputs. In the previous exercise, we decoded a secret message found in the transaction input. And this time, we will be looking at an output. For the following transaction, we are going to identify output of type op return. There is another way to hide secret messages in transactions, encoding data in the op return. It's been very topical recently. Bitcoin has a special type of code called the op return that allows users to attach messages into transaction outputs. Let's see if we can find one. So we're going to look at a specific transaction right here. We have the Blockstream Explorer once again, and we can also use mempool.space. We can use either, it's interchangeable. And we have our transaction hash. I just want to show both and how they appear differently in each. We can see which block this was from 3 years ago. We can see our transaction with the inputs and the outputs, and we see some op return data right here. District 21, the Bitcoin Freedom Zone. Okay, it seems like some arbitrary data has been encoded into this output, and the output has 0 BTC associated with it. Let's see what the question is asking for. We're going to open the details and find the part of op return. Locate the script pub key, ASM, which is assembly, and see the op return push bytes 33 parts. These are the op codes, and we're interested in what comes after them. So we're going to copy the long string of numbers after the op return and paste it into the code block. So we open up the details of that transaction, and we can see the locking script over here. In the inputs and the outputs, we have the unlocking script as the transaction is spent, as the input is spent, and then the locking script for the outputs. So we see the op return, push bytes 33, and we're going to copy and paste this value into the browser. Nicely done. And we have another secret message that we're going to decode now. So we have this data, this information, this code that we copied contains data that we are going to now decode. You'll notice that here it's encoded, and we are going to decode it. And the web browser has done it below in the upper turn data, but we are going to do this manually now. So we're going to type in our command echo. This time, the web browser has not saved the variable for us, so we're going to paste in the string directly, and then finish up with the command directly above. Very good. So we can see that this string right here has encoded District 21, the Bitcoin Freedom Zone. As you can see, the clue is an address. The next challenge awaits you. You run down to your garage and step into your dad's old budget copter, punch in the coordinates, and make your way to District 21. Despite cat allergies so intense that they apply even to holograms, the holocat comes along. You object, but cats will be cats. So, congratulations everyone for completing chapter 1. If you're up to this point, you can save your progress, share on X how far you've come. We'll back up our key right here. This is how we track. This is how also old video games did this, where you have a code at the end of a level to track your progress. So we can back that up and continue on to chapter 2. Very good. The coordinates Satoshi gave you don't disappoint, unfortunately. It's a warehouse, and a scary, deserted one to boot. This is the District 21 that we decoded in the previous transaction. You circle the warehouse in your budget copter no less than 3 times. Yeah, you're probably gonna have to go in there. Your budget copter's budget heat detector detects nothing but darkness. If someone knows that this place exists, it's been a long time since they visited anything but their memory. Very good. Can I get another volunteer come up to be the next voice for Holocat? Would anyone like to come on down? Yes, please, Luke, thank you. Yeah, let me click it on. Yeah. Blue. Try the other one.
Maybe I'll use the other one.
Oh, now it's working, yeah.
Classic.
Okay. Boy, what a dump. This place had better have some anchovies stored somewhere. I'd even settle for some cyber kibble.
You stand steadily yourself and search for a point of ingress. There, that broken window should do the trick. You take out what's left of the window with a brick and hop inside. The building is filled with thousands of dusty, well-preserved Bitcoin miners.
This isn't a warehouse, it's a museum. I think these are old Vanderpool family mining devices. In Bitcoin's early days, miners would use general-purpose computers to mine Bitcoin. But after a few years, miners realized they could use machines with a specialized chip called an Application-Specific Integrated Circuit, or ASIC for short. These chips do only one thing: mine Bitcoin. Their narrow focus increases their efficiency and allows miners to spend less energy on mining, giving them an edge. Can you believe that people mined with their laptops at one point?
This explains all the machines in the Vanderpool family collection. Oh, hold on, wait. Yeah. Hashing out a plan. In the corner, a dim, barely working computer monitor with a note stuck to it sits blinking. The note says, "Turn them on, stupid."
How rude. Wow, a mechanical keyboard. I've heard about these things. Supposedly they were so loud that they cost users their hearing and were banned.
Holocat jumps onto the keyboard and walks across it, showing you what keys to hit. Either by chance, or because Holocat actually knew what she was doing, the random letters and numbers she stepped on turn into more random letters and numbers. So we can see here, there was some input onto the keyboard and then some type of output. The monitor displays incorrect hash, try again. Of course, whatever gibberish Holocat typed was wrong. She's just a sassy holographic cat. What happens if you type something different? So, thank you, Luke. So now we can begin here just by typing. And you'll notice that as we input and type into our keyboard, there's some type of output, a hash, at the bottom of the screen. Oh. Is everyone following along to this point? Everybody set? Okay, very good. Did you notice anything special about the hashes? Just like fingerprints, hashes are unique. Barring some exceptional circumstances, the hashes for two different things should never be the same. Hash functions are one-way streets. You can't reverse engineer a hash to figure out the data used to make it. Hashes are extremely reliable in the sense that they are deterministic. That means that you can hash the same piece of data over and over again, and you will always get the same result. The function used here is called SHA-256, a very popular choice, and the hashing algorithm used in Bitcoin. Now, let's see if you can find a specific hash. Find a hash that starts with a 0. Keep typing different things below until you find a hash that we want. So this exercise is leading us into understanding how Bitcoin mining works and the SHA-256 hash function. So I can type various keys, various letters in here, and you'll notice at the bottom, my input is being converted into a hash. And as I keep adding on letters, we eventually get to one where we have a leading 0 in front. So we're trying different inputs into the hashing function until we get a desired result in the end. This is related to Bitcoin mining, and we're going to explore a little more details as to how shortly. So we found one here. We found this great word that I've written. Gives us the desired hash. Now we're going to make it a bit more tricky and find a hash that starts with 2 zeros. So we can keep typing now. Oh, found another one. Very good. Now, that probably took us longer. Imagine finding a hash that starts with 5 or 10 zeros. This is the challenge that the Bitcoin network poses to miners when they want to submit new blocks with transactions. Miners gather all the information they want to put in a block, such as the previous block header hash, a hash of transactions to be included into the block, time, and combined it with a random number called the nonce. Nonce is the number only used once. They send all of this into the hash function to create something called the block hash. When Bitcoin first launched, miners would cycle through the nonce in the block header by incrementing the data in the 32-bit field by 1. However, as miners become more powerful and more efficient, the difficulty rises. It became so high that it was common to exhaust all possibilities for the 32-bit field without finding a single solution. To address this, miners started to change other parts of the block header, such as the time or transactions included. So now we have our first coding exercise of the workshop. And what we are going to do is we are going to write our own code that is going to run the hash function until we find a desired output with 5 leading zeros. This resembles the work done by a Bitcoin miner. So just as we've been trying one at a time to try different hashes and get a desired output, this is the application of the ASIC. So the ASIC is the application-specific integrated circuit. It's doing one thing. It's running that hashing function. So we have our code terminal up, and now our challenge is that we are going to write some Python or JavaScript code that will give us the desired output. So we can try this on our own first. Does anybody have any ideas about how we could approach this problem? I can see we're importing from the SHA-256 library. We're looking for a desired value to come from this. Does anyone have any ideas of how we can begin? Okay, maybe a loop to try while until we find the output that we're looking for. We have a code solution ready, and I can walk you through line by line how that is going to work. So if you go up to the top, if you click the question mark in the top right, it will open up a learning resources panel and a spoiler where you can copy in the solution, and we're going to talk through that. The next challenge is I won't be able to spoon feed it to you. So we begin with a blank hash value. I'm going to zoom in if I can on the screen. And while the first, so we begin with a blank hash. So while the first 5 digits of the hash are not equal to 000, we will generate a new hash with the SHA-256 function in Python until the value gives us one that has 000 in front. And we'll iterate through the nonce. So you see the nonce is being used as an input, and we iterate through the nonce until we have a desired output. So we can now run the script. Great. So what happened here is that this ran many times until the hash function returned us a value of 5 zeros in the front, 794. As you all run this program independently, you should probably have different values of this. Is everybody caught up to this point? I'll wait for the participants in the audience. Yes, all good. Fantastic. Now that we know how mining works, let's see it in action. So right now, the Bitcoin network requires blocks to have a hash with 10 leading zeros. Let's get to it. For this simple simulation, we'll assume that every block contains 3,500 transactions and 0.061 BTC in rewards and fees. This is towards the very end. Currently, the block reward is significantly higher than that. So let's turn on the miners. So we're mining now. The code you wrote in the previous lesson is running. And we found one resulting hash with the 10 leading zeros. It has the 10 leading zeros that all new blocks require. Let's mine some more. Let's turn the miners back on. We're going to get to 100 blocks. We're going to hit the 100x button to speed this up. Very good. Right now, we're simulating the ASICs running that hash function over and over again until we find the desired hash output that will result in us mining a block. We did it. That took quite a bit of computing power to do all the hashing. Just look how many nonces we tried. Let's see. 19 to the 19.42 times 10 to the 19 is quite a bit. It really helped to have that boost in hash power when I click the 100x button. The number of hashes your computer can try in a second. Let's learn more. Since each block contains 3,500 transactions, 350,000 transactions have been confirmed. And we've collected a reward of 6.1 Bitcoin. These are the rewards cumulative of all the blocks that we mined in this exercise. Each block takes about 10 minutes on average, more or less. And if we were really mining on the current mainnet, it would take many orders of magnitude of more computing power to mine the blocks. Very good. So the machines roar to life. Everything seems to be working, and a map appears on the old monitor that shows the locations of other warehouses filled with other Vanderpool mining devices that have come up online across the world. They were activated as we completed the mining challenge. Holocat. Look, there's a message. Good work. This will help Bitcoin get back to 1 block every 10 minutes. Satoshi Nakamoto. Him again? Very good. So now that we've walked through the first two chapters through the screen, we'll independently continue with chapter 3. I'll be going around to help assist through the exercises, and we'll have some nice music playing in the background throughout the experience. So, thank you. So begin with chapter 3, and sorry? Yes, and we have all sorts of excellent goodies that we'll be bringing around. We have socks, stickers, and many more goodies for everyone to take home. Merch that you can wear to your next Bitcoin meetup and the next Bitcoin conferences. So, thank you very much.